Hello all. In this video, we will go over the most recent mechanics M1 paper. This is from the international A-levels, the mathematics route, okay? And this is the first paper I do on mechanics M1. It was fun. I know that nobody's going to watch this video during the summer, but I'm going to put it out there, and if anyone finds it useful, it can be watched at a later time. So this paper lasts for 90 minutes. So the thing I always say about papers, try to spend about a minute, maybe 2 minutes per mark. So if a question awards 10 marks, it should take you about 10-15 minutes. If it takes you more than 20, you will probably run out of time at the end of the paper. So it's better to pace yourself. The other thing is read the questions thoroughly, okay? Half the answer is in the question, okay? So if you understand the question perfectly, you will be able to solve the paper, make use of whatever formulas you can take with you with these papers. Take advantage of what else? Okay, the formulas. I mean, sometimes you might be inspired and find the solution there. And also, try to work on the problems you are comfortable with first so that you build momentum and confidence, and then you can return to problems that bothered you in the beginning and you didn't know how to start them and solve them after you have solved everything you know how to solve. Okay, I hope this makes sense. Okay, because sometimes you might start working on a problem that you don't know what to do with. Okay, and then your momentum is lost, your confidence is destroyed, and then that might ruin the whole paper. But maybe it was just that question. Okay, so don't allow one question to destroy the possibility of you getting a really good mark in a paper. Okay, so let's dive in. With question 1, a particle P of mass 3m and a particle Q of mass 5m are on a smooth horizontal surface. The particles move towards each other in opposite directions along the same straight line and collide. Immediately before the collision, the speed of P is 3u and the speed of Q is 4u. The magnitude of the impulse exerted on P by Q in the collision is 33rd halves times m times u. Find question I, the speed of P immediately after the collision. Okay, let's do that and then we will move to part 2. So let's draw a quick sketch of the situation. I don't know why my marker was selected to white. Okay, let's do black. Okay, so this let's say that this is the smooth horizontal surface, and okay, maybe this is particle P of mass 3m moving with velocity 3u to the left, and maybe this is the other particle Q with mass 5m moving with velocity 4u to the left, and we take overall the direction to the right to be the positive direction. Okay, so with this convention here, I mean right being positive, the impulse, okay, on P by Q is minus 33 times m times u over 2. Okay, and the reason is because Q moves to the left, whereas the positive direction is taken to the right. Okay, I hope this makes sense. So let's solve question I. The impulse, okay, is equal to the change in momentum. Change in momentum of P. Okay, so let me fix that pop-up in the bottom of the screen. Okay, so the impulse then, so I is delta P, is what I'm trying to say, which means that minus 33 times m times u over 2 is equal to the final momentum of p, let's call it 3 times m times v, okay? So this is the final momentum, so p final, minus the initial momentum, which is 9mu, okay? So that's pi. Okay, I hope this makes sense. Okay, and v is the velocity we are looking to find because we don't know what the final velocity is. So let's solve this equation. We have 3 times m times v is equal to minus 15 mu over 2, and m cancels, which means that v is finally minus 5/2 u. Okay, which means that the particle will turn around and move to the left. Okay, so we will have an inversion in the velocity, okay, due to the collision. Okay, I hope this makes sense. Let's move on. Part 2, the speed of q immediately after the collision. Okay, so we have to find it. Okay, yeah, find the speed of q immediately after the collision. Okay, so let's work on that problem here. So the impulse on, sorry, not off, on, impulse on q by p is plus 33 times m times u over 2 because of Newton's third law. Okay, for every action we have an equal and opposite reaction. So because, let me write it again, of Newton's third law. Okay, so we are going to do the same exact thing but on q. So I is delta p, which means that plus 33 m times u over 2 is equal to 5m times v, let's call it q, okay, to distinguish from the other v, okay, minus of minus 20 mu, okay, so that's important. So this is the final momentum and this is the initial momentum, okay. To find delta p, we have to subtract the final momentum minus the initial momentum, right? So in our case, because the initial momentum is negative because q moves to the left, remember that? So we get that equation, and if we solve it, we find 5 v q is m cancels like before, so m goes away, okay, and so 5 vq is 33 u over 2 minus 20 u, which means that vq is minus 7/10 u. Okay, so q keeps moving to the left but with a much lower velocity. Okay, and I guess it's because it transfers a lot of its momentum to first kind of stopping p momentarily and then inverting the direction of motion of p. Okay, because p was initially moving to the right, so by this impulse it starts moving to the left. So a particle q loses a lot of its momentum in that process. Okay, so let's move on to question number 2. Okay, question 2, we have a speed versus time graph. Okay, interesting. So a particle p starts from rest at time t equal to 0 and moves in a straight line. From 0 to 12 seconds, p accelerates uniformly until it reaches a speed of 3u meters per second. From 12 to 31 seconds, p moves with constant speed 3u meters per second. And from 31 to 41 seconds, p decelerates uniformly until it has a speed 2u meters per second, as shown on the speed time graph in figure 1. The distance traveled by p between t equals 0 and t equals 41 seconds is 600 meters. Question A, show that u is 6, I guess, meters per second. I don't know why they exclude that. No, u is actually 6. I'm sorry, because they say, here they say 2u meters per second. So So the constant determines the meters per second. I hope this makes sense. So what I'm trying to say is that what they are saying here is that we have 2 meters per second times u. So u is a variable that has no units. Okay, so I was wrong about the problem. Okay, the area under the curve gives us the total distance traveled, right? So let's do it here. So area under the curve is equal to the total distance. And how do we know that? Because in general, the area under the curve is going to be some constant, and then times, so it's going to be some constant times v times t, which means that the dimensions for this quantity is going to be, the constant is dimensionless, v has units of meters per second, and times has units of seconds. So we see that the area represents a distance, and specifically the distance traveled by the object. Okay, so let's split this into 3 areas. Okay, so this is area 1, which is a triangle. Area 2 is a rectangle, and then area 3 is a trapezium, right? So let's write down that area 1 plus area 2 plus area 3 is 600 meters, okay? Which means that we have, for the triangle, 1/2 times the height is 3u, okay, and the other side is 12, right? Okay, plus the area of the rectangle, 31 minus 12 times 3u, plus the area of the trapezium, which is 3u plus 2u, the two bases, times the height over 2. And this whole thing is 600. Okay, so we have 18u plus 57u plus 25u is 600, which means that u is 6 meters per second. Okay. B, find the distance traveled by P whilst moving from rest to a speed of 6 meters per second. Okay, so this is related to this part of the graph. Okay, how do we know this? Because the speed up there is, if u is 6, the speed up there is 18 meters per second. Okay, so it starts from rest here, and somewhere there, okay, at this point, it develops a speed of 6 meters per second. I hope I make sense. Okay, so first of all, we need to find the gradient of this line, because the gradient gives us the acceleration. Okay, so let's do B. The acceleration is delta V over delta T, pretty much. So we have 18 over 12. So 1.5 meters per second squared is the acceleration. And we can find, what do they ask? Find the distance traveled. Okay, so we have the acceleration. From the velocity suvat equation, we can find the time needed to travel between these two speeds. Okay, so what I'm saying is that v is u plus at, which means that, okay, the final velocity, the initial velocity is 0, so t is v over a, or 6 over 1.5, which means that that's 4 seconds. Okay, so the area under the curve will give us the distance again. So we have 1/2 times 6 times 4. So 12 meters is the distance it will travel. Okay, I hope it makes sense. Let's move on to part C. Find the acceleration of P between t equals 0 and t equals 12 seconds. We already did that. Okay, so I'm gonna code it, but the calculation was done up here in the box. Okay, So 1.5 meters per second squared, okay. D, find the deceleration of P between 31 and 41 seconds. We will find the gradient, in other words. So let's do D. The acceleration, deceleration is delta V over delta T. In this case, we have 2 times 6 minus 3 times 6. And I'm saying that here the velocity is 3 times 6, and here the velocity is 2 times 6, okay? And then we have to divide that by the total time, which is 10 seconds. And we find minus 0.6 meters per second squared, okay? And part E, sketch an acceleration time graph to represent the motion of P from 0 to 41 seconds, okay? So we have all the information, so it should be straightforward. So, okay, that's the acceleration, that's the time. So acceleration in meters per second squared and time in seconds. So here are the 12 seconds, let's say. Here are the 31 seconds, and here are the 41 seconds, okay? So we have an acceleration of 1.5 at some point, and then, okay, somewhere there, it's the minus 0.6, okay? Something like that. So from 0 to 12 seconds, we have an acceleration of 1.5. So that's the acceleration. From 12 to 31, we don't have acceleration, okay? Because it's flat there, so the gradient is 0, okay? So that's the acceleration. Okay, and then from 31 to 41 seconds, we have an acceleration which is constant, equal to minus 0.6 meters per second square. And this, guys, was problem 2. I hope it makes sense. If it doesn't, ask me in the comments, and I always provide explanations if needed. But let's move on to question number 3. Okay, question 3. I have to confess that I messed up my first trial on this. It's a shame, I know, but it happens, okay? And I will let you know where I messed up. So, a particle moves on a smooth horizontal plane under the action of 3 horizontal forces, F1, F2, and F3, given there, okay? So these forces are proportional to P and Q, which are constants, okay? So it is stated there, okay? The resultant force acts in the direction of the vector 4I hat minus 5J hat, okay? And again, these are the unit vectors, okay? So if we have an x-axis and a y-axis, I hat is a unit vector, meaning that it has a dimension of 1, okay, in the positive x direction, and j hat is a vector, again, dimensionless, in the positive y direction, okay. Show that 2p minus q is 19. Okay, so what I messed up, okay, what I messed up was, okay, first of all, we have to find the sum of all forces, okay, the resultant force, okay, and this resultant force, I was very tempted to say that this resultant force is 4I hat minus 5J hat, okay? That's wrong, okay? Because they tell us in the direction of the vector, okay? So in the direction of the vector means that the resultant force is proportional to that vector. So what this means is that the sum of all forces is some constant, let's call it lambda, times 4I hat minus 5J hat, okay? And that constant lambda might be 1, might be 10, might be a billion, might be 0.1, whatever, okay? So this is what I messed up. Now let's sum these vectors. So F1 plus F2 plus F3 is lambda times 4I hat minus 5J hat, okay? So we get 2p plus q plus 3I hat, okay? minus 3p plus q minus 1 j hat is equal to lambda times 4I hat minus 5 j hat. Okay, let's put this in parentheses. Okay, it's better. So this means that the I hat component has to be on the left hand side, has to be equal to the I hat component in the right hand side, and the j hat component on the left hand side has to be equal to the j hat component in the right hand side. But you have to be careful because of that lambda factor. So we have 2p plus q plus 3 is equal to 4 lambda, and then we have 3p plus q minus 1 is equal to 5 lambda. Okay, and we can solve for lambda, so lambda is 2p plus q plus 3 over 4, and then from the other equation we have lambda is 3p plus q minus 1 over 5, and of course these two lambdas are the same, so we have that 2p plus q plus 3, 2p plus q plus 3 over 4, okay, is equal to 3p plus q minus 1 over 5, okay, which means that 10p plus 5q, I'm cross multiplying, right? Okay, I hope this makes sense. So 10p plus 5q plus 15 is 12p plus 4q minus 4, which means that 2p minus q is 19, which is what they ask us to find. Okay, I'm sorry it took a long time, but we arrived at this conclusion. Okay, so I hope it makes sense. Let's move on to the next part. The mass of the particle is 0.5 kilograms. Given that p equals to 7, excuse me, find the acceleration of the particle. Okay, do we have space here? Yes, we do. Maybe I will solve it here. So part B, if p is 7, okay, q is minus 19 plus 14 or minus 5, right? So sigma f is equal to, where was sigma f? This was sigma f, okay? This is the resultant force, okay? So we can actually find the sum of all forces because we now know P and Q, and that's equal to 12 I hat minus 15 J hat, okay? But remember that the sum of all forces is equal to MA, so MA is 12 I hat minus 15 J hat, so A is 12 over 0.5, which is 24 I hat minus 30 J hat, okay? So that's the acceleration. All right, so to find the magnitude of the acceleration, we have to find, so this is acceleration in vector form, I'm trying to say. Now we can actually find the measure of sigma f, which is going to be the square root of 12 squared plus 15 squared, or 19.2 newtons. But the magnitude of sigma f is equal to the mass times the magnitude of the acceleration. So we can also find the acceleration, the magnitude of the acceleration, as 19.2 over 0.5 or 38.42 meters per second. And of course, you can also do the magnitude of A can also be found by the square root of 24 squared plus 30 squared. I actually haven't tried it. Let me pull out my calculator and calculate it to make sure that the process was correct. Let me see. So yeah, we find the same thing. So 38.42 meters per second squared. Okay, this was question 3. I hope my explanations are clear. Let me know what you think about them in the comments. But let's move on to question number 4. Okay, question 4. Figure 2 shows a uniform rod AB of length 6 meters suspended by 2 light vertical ropes. The first rope is attached to the rod at A. The second rope is attached to the rod at the point C, where CB is 0.4 meters. The rod has mass 30 kilograms. A particle of mass 20 kilograms is now attached to the rod at B. The rod is in equilibrium in a horizontal position. Okay. A, find I, the tension in the rope attached to the rod at C, and 2, the tension in the rope attached to the rod at A. So let's write down. Let's write down all the forces exerted on the rod. So those are the tension by the rope that pulls up at A, and same at C. I'm not saying they are the same force. I'm saying that it's the same situation. Force pulling up. Okay. Then in the middle of the rod, excuse me, we have the weight. Okay. Pulling down, and this will be 3 meters. Okay, because the center of mass of a rod is in the middle. Okay, and we also have the weight of the other object. Let's call it m times g. Okay, and actually maybe let's call this one capital M times g. Okay, so 4 forces in total. Then in part A, since the rod is in equilibrium, that means that TA plus TC is equal to m times g plus capital M times g, right? And now let's take moments about A. Okay, those have to balance since the rod is balanced. Okay, so moments about A. Okay, so we have 2 forces that want to rotate the rod clockwise and one that wants to rotate it anti-clockwise. Okay, and these have to balance around A. So we have capital M times G times 3 meters, right? That's the mass of the rod, plus lowercase m times G times 6 meters should be equal to TC times 5.6 meters. Okay, so we can immediately find TC. So TC is 30 times 9.81 times 3 plus 20 times 9.81 times 6 over 5.6. So this is 367.9 newtons. Therefore, TA, we can plug into the first equation that we found. Okay, so TA is 30 plus 20 times 9.81, which is the weights of the 2 masses, minus what we just calculated, 367.9. So TA is, so this would be part 2, I guess. So TA is 122.6 newtons. Okay, I hope it makes sense. So let's move on to part B. The particle of mass 20 kilograms at B is removed and replaced by a particle of mass capital M. Okay, now we will have a problem with my notation because capital M used to be the mass of the rod. We will fix it. So anyway, of mass capital M kilograms, the rod remains in equilibrium in a horizontal position. B, find the exact maximum value of capital M. Okay, and we have space. We do. Okay, let's do B. So S So we add heavier and heavier mass at B, right? Heavier mass at B, comma, TA gets smaller and smaller, gets smaller and smaller. Okay. And you can see this from the equations, right? Because if we increase, so this is the mass at B, okay? So let me show you. Oops, I'm sorry. So this is the mass at point P. If I make that 300, okay, you immediately see that, let's say that I make it 300 kilograms, then TC is going to be much larger than 367 newtons, which means that TA, because TA is calculated by subtracting TC from the total mass of the object and the mass of the rod, we'll see that TA gets smaller. Okay, I hope this makes sense. So this is the best explanation I can give. Okay, I mean, from the math of the problem, you can see that as we increase the mass at B, TC gets very, very large, whereas TA becomes much, much smaller because we have to subtract TA. Okay, so TA gets smaller and smaller until eventually, okay, eventually TA becomes 0, okay? If TA is 0, let's take moments around C, okay? So we will take now moments around this point, okay? Which means that, okay, let me erase a few things. So I hope I'm not confusing you, okay? So if we take, okay, now this becomes, I'm sorry, now this becomes capital M times G, and let's call this M prime G. Okay, if we take moments around C, this is now a clockwise moment, and okay, this wants to turn it clockwise, and this wants to turn it anti-clockwise, right, in the opposite direction. Okay. Yes. Okay. So what did I do? Let me see. So yes, that's correct. Okay. Yeah. So 30 times 9.81 times 2.6, which is the distance of this mass of M prime from C, it's 2.6, should be equal to capital M times 9.81 times 0.4, which is the distance of capital M from C. So G cancels, and we find that mass is 195 kilograms. Okay, so if that mass is 195 kilograms, then TA becomes 0 pretty much. Okay, so what I told you up there is actually wrong. Okay, so the maximum mass is actually 195 kilograms. Okay, so I hope this makes sense. We are ready to move on to question 5. Okay, question 5, the points O, A, B, and C are on a rough horizontal surface where O, A, B, C is a straight line. The particle is projected horizontally from O and slides across the surface, passing through A, B, and C in that order. The particle passes through A with speed u meters per second, B with speed u over 2 meters per second. The coefficient of friction between the particle and the surface is 1 over 7, excuse me. It takes 0.75 seconds for the particle to move from A to B. A show that u is 2.1 to two significant figures. Okay, so with these problems is always good. I forgot to mention it earlier, even though we did that. I mean, in all the problems, we try to take advantage of the scheme, right? Okay, except here, question 3 was just pure math. So, but anyway, it's good to draw a scheme so you have a mental model in your head about what's going on. So, we have a horizontal surface, okay, and we have a projectile or a particle, as they say, projected to the right and moves along this surface. Okay, it starts. It's actually projected from O, so maybe. So okay, let's put O here. So it starts from there. It passes through A with velocity u meters per second, and B with velocity u of okay, so u meters per second, and then u over 2 meters per second. It also passes through C. We will see later what the condition there is. Okay. So we need to do a few things first, since they give us a coefficient of friction. So okay, let's start with question A. Okay, so we're given the coefficient of friction as 1/7 and TAB as 0.75 meters per second. Let's draw the forces on this particle. Okay, those are going to be its weight, the reaction from the floor, and the friction, which points to the left because friction resists the motion, and the motion is to the right. Okay, so the equations are of motion are r is m times g, because there is no motion in the y direction. I mean, the particle is not moving in this direction. Okay, so the forces are balanced there, and then the friction provides deceleration. Okay, so the friction, which is actually equal to the coefficient of friction times the vertical force. Okay, so the friction is mu times m times g, but this friction is the sum of all forces in the x direction. Okay, I hope this makes sense. So sigma f is minus f, because f points to the left, right? So mass times acceleration is equal to minus mu times m times g. So we find the acceleration immediately as minus g over 7. Okay, and then we can apply suvat equations. So final velocity is equal to the initial velocity plus a times t. Okay, so the final velocity is u over 2. The initial velocity is u, right? Minus g7 times tab. Okay, so if we solve this equation, we will find that u is 2g over 7 times tab. And if we plug in numbers, we will find 2 times 9.81 over 7 times 0.75. So that's 2.1 meters per second. Okay, so it takes a little bit of work, but eventually you can arrive at the answer. Okay, B. No, before we read B, let me see. Yeah, we have to read this sentence. The particle passes through C with speed u over 3 meters per second. Okay, so here we have u over 3 meters per second. Okay, find the time taken to move from B to C. Okay, so we will use suvat again. So u over 3, which is the final velocity, is u over 2, the initial velocity, minus g over 7 times tbc. I mean, the deceleration is the same, nothing changed. Okay, so g over 7 times tbc is u over 6. So tbc is 7u over 6g, or TBC is 0.25 seconds. Okay, so that's the answer. And the last question, part C, asks to find the distance AC. Okay, so that's our distance. Again, we can use suvat. So S is U times T plus 1/2 AT squared, right? So the initial velocity is 2.1. Then the total time, let me write it here. So the total time t is TAB plus TBC. So that's 1 second pretty much, right? So this is what we will write there. So 1, okay, minus 1/2, minus because it's a deceleration, right? 9.81 over 7, that's our acceleration, which is 9.81 over 7, right? Minus of that. So anyway, let's erase this. We don't need it. Times 1 second squared, okay? So this gives us 1.4 meters, okay? And this was question 5. Okay, let's move on to question number 6. Okay, question 6. In this question, I and j are horizontal unit vectors directed due east and due north, respectively, and position vectors are given relative to a fixed origin O. Okay. At 9 a.m., a ship S leaves a harbor and moves with constant velocity 10 I hat plus 15 j hat kilometers per hour. A, find the exact speed of S. Okay, they say exact, meaning that we cannot use decimals. Okay, so we basically have to find the magnitude of the velocity vector. So the magnitude of the velocity vector is the square root of 10 squared plus 15 squared. So let's do some mental gymnastics. So 10 can be written as 2 times 5 squared, and 15 can be written as 3 times 5 squared. Okay, so that's the square root of 5 squared, and then times 4 plus 9. So that's 5 root 13 meters per second. Okay, hope this makes sense. I think this is the easiest way to show this. I mean, find the exact value. Okay, moving on. The harbor is at the origin O. Okay, at 9 a.m., a boat B, okay, so this is a different boat from S, leaves the point with position vector 50i. Wait, let me see. Moves the point with position vector 50i hat plus 10j hat kilometers, and moves, with constant velocity minus 8 I hat plus 10j hat kilometers per hour. Question B, find the direction in which B is moving, giving your answer as a bearing to the nearest degree. Okay, I had to actually Google that because I never really used it before in my life. I mean, I could kind of sense what they meant, but I didn't know. So let's answer B here. So basically, they tell us that, let me think. Okay, so this is the velocity of this boat, of this second boat. So 10 j hat, okay, is the component of the velocity in the y direction, and in the x direction is okay. Let's say this is minus 8 I hat. Okay, which means that our position vector for the vector for the velocity, not the position, excuse me, is this one. Okay, I hope this makes sense. So this is the velocity of B, right? And it makes an angle theta, okay, which you can calculate. So let me see. The direction in which B is moving. Okay, so the tangent of theta is simply 10 over 8, okay, which means that theta is 51.34 degrees. Now the bearing is the angle with respect to the nearest degree north, okay? So this is the north, right? And the east is actually here, okay? So that's our east. So how many degrees? So the bearing is going to be 270 degrees because, I mean, this is the angle pretty much, right? This is what we are looking to find. Okay, so 270 plus 51.34, so 321.34 degrees from north. Okay, so that's the answer. Now, C. Show that at time t hours after 9 a.m. as B is 50 minus 18t I hat plus 10 minus 5t j hat kilometers. Okay, so this is the vector that takes you from both S to both B. To do that, let me see. I hope this is not going to be confusing. So for okay, let's do C in this clean page. So the position vector, let me think. So the position vector of both B. Okay, so actually let me write it here. So both B. Okay, its position vector is 50 I hat plus 10 j hat. So it starts from there. Okay, it doesn't start at the origin like the other boat S. Okay, and its velocity is minus. So this is the position vector, and that's the velocity vector, 8 I hat plus 10 j hat kilometers per hour. Okay, so in general, the position vector of the boat B is going to be equal to the, let's call this R0, which means R0 is the initial vector position of boat B, and V is its velocity. Okay, so the position vector of B, maybe I will create a clean page. This will make more sense. Okay, so this is the origin. Okay, and both S, let's start with S actually. I think this is going to help you. So S moves pretty much northeast, right? In that direction in general, because leaves the harbor. Okay, so if that's the origin, then both S moves in this direction. Okay, pretty much, and then B at the same time, B is at the position vector, this one, okay? So it's somewhere up here, pretty much. Okay, so this is B. And it moves in this direction that we showed earlier, okay? Let me see. I hope I'm not getting you dizzy. Yes, 50i plus 10j. Okay, maybe it's actually here. So somewhere there. Okay, it's better to put it that way. Okay, because there is the possibility that they collide, and it moves in this direction. Okay, so this is both B. Okay, I hope it makes sense, because S starts at the origin, B starts somewhere here. So this is X and Y. Okay, so in the position vector space, okay, B starts. So maybe this is the position vector, and the position vector is, so that's what we call R node. That's 50 I hat plus 10j hat. Okay, so that's the position vector of B, and it moves in that direction, whereas S starts from origin. Okay, so let's go back. So RB, the position vector of B at all times, because then since B is going to be moving, this is the initial position vector, but then it's going to move in this direction. So maybe at a later time, this is going to be RB, and then it's going to keep moving in this direction, which means that the position vector will be moving for B. Okay, so RB at the random time is going to be R naught plus V times T. Okay, so we have 50I hat plus 10J hat plus minus 8 times T, because T is a constant, so it multiplies both components of the vector of the velocity vector, okay, plus 10t times j hat. Okay, so RB is going to be 50 minus 8t I hat plus 10 plus 10t j hat. Okay, now for both S, okay, so this is both B. Now for both S, okay, for both S, R naught is 0 because it starts from the origin, right, guys? And V, actually, it would be better if I said here that this is V, so R naught B, and this is V, B. Okay, so R naught B, and this is V, B. Okay, I hope this is clearer now. And then similarly, this is going to be the initial position vector of S, 0, and then Vs is, what was it? 10i plus 15j. Okay, so 10i hat plus, oops, plus 15j hat. Okay, so this means that Rs is going to be R naught S plus Vs times T, or 10t I hat plus 15t j hat. Simple as that. Okay, and now to find the vector SB, we have to subtract Rs from RB. Okay, because if we go back to this silly drawing I made, okay, let me erase a few things. So remember, we have our boat S, okay, that moves in this direction. So maybe at some random position, oops, okay, maybe at some random position, this is the position vector Rs of S, and then maybe that's the position vector of B, okay, so that's RB, and again, these move towards each other. So what we are trying to find is SB is this vector pretty much, SB, okay, so SB, so RS, pretty much RS plus SB is equal to RB. I hope I make sense. So SB is RB minus RS. Okay. So let's go back here. Actually, let's do it here. So SB is 50 minus 18t I hat plus 10 minus 5t j hat. Okay, so that's the position vector. Okay, I hope it's clear. Let's read question D. So this is a long problem, guys. So D, show that B and S do not collide. Okay, so that's question D. So we will work with this vector to see if they collide. So this is D. So if S and B collide, this means that SB becomes 0 because they arrive at the same point at the same time. Okay, so SB becomes 0. For that to be true, though, for that to be true, we must have both the I hat component and the j hat components equal to 0, okay? Which means that we need 50 minus 18t equals 0, which gives t equals to 25 over 9. And we also need 10 minus 5t equal to 0, which gives t equals to 2, okay? So, times are different, okay? Different, which means they don't collide. Don't collide. So what these times tell us is that after 2 seconds, the y direction, the y component of the vector becomes 0, which means that they are on the same line on the x-axis, and then at 25 over 9 seconds, the x component becomes 0, which means that they are perpendicular to each other as you see them from above on the xy plane. I hope this makes sense. If it doesn't, ask me in the comments and I will provide more explanations, but think about it. Okay, but they definitely don't collide. Okay, and there is a part E, because this is a long problem, guys. Okay, when B is northeast of S, the distance between S and B is d kilometers. Find the value of d. Okay, so northeast means that okay, actually let me create a clean page to explain it. Okay, so this is our north, this is our north, and this is our east. So northeast means that this is 45 degrees and the components become equal. Okay, so x and y components become equal. Okay, so northeast means 50 minus 18t becomes equal to 10 minus 5t. Okay, which means that 40 is 13t, which means that t is 3.08 seconds. Okay, and then the distance between these boats is going to be equal to 50 minus 18 times 40 over 13 squared, okay, plus, so I'm taking these components pretty much and I'm plugging in the time at which the northeast situation happens, okay, and we find D. Okay, so plus 10 minus 5.5 times 40 over 13 squared, so we get 7.6 meters. And suddenly I'm terrified that I actually haven't checked the mark scheme about all these answers. So let me do it really quick. I have it in front of me. I never really follow it because it confuses me sometimes. Okay, they have some bizarre ways of solving problems sometimes, so it doesn't help me. It confuses me, but we have to have the same answers in the end. Okay, 7.6, not meters, kilometers, guys. I'm sorry. Okay, this was a very long problem. This was question 6. Let's move on to question number 7. Okay, question 7. A rough plane is inclined at an angle theta to the horizontal where tangent of theta is 4 over 3. One end of a light inextensible string is attached to a package P. Okay, the string passes over a smooth pulley that is fixed at the top of the plane. The string from P to the pulley lies along a line of greatest slope of the plane. The other end of the string is attached to a baguette. The package P has mass 1 kilogram and is held at rest on the plane. The baguette has mass 0.45 kilograms and hangs vertically below the pulley with the string taut, as shown in figure 3. The coefficient of friction between P and the plane is mu. When a small block of mass 0.2 kilograms is placed in the baguette, the system is released and remains at rest in limiting equilibrium with P on the point of slipping down the plane. Okay, down. It's important, as we will see. Okay, question A. Show that mu is 1 over 4. Okay, so we're going to draw forces. Let me think about how I want to handle this, because it takes some work to figure this out. Okay, let's use the scheme that they give us there to draw forces. So how many forces do we have? First of all, we have the baguette that has an extra mass in there. So let's say that the weight is m2 plus m3 times g. Okay. where M2 and M3 are the masses of, so M2 plus M3 is pretty much M2 plus M3 is 0.45 plus 0.2 or 0.65 kilograms. Okay, that's the mass of the bucket plus the extra mass. Then we have the tension from the rope that points up. Then the same tension pulls up the box at P. Then we also have the frictional force. Okay, so that's the T. We have the frictional force that points upwards, and the reason is this phrase over here. P on the point of slipping down the plane. So if it's at the verge of slipping down, okay, on the plane, then the friction is up because it resists that slipping. Okay. What other forces do we have? We have the weight. Let's call it M1G of the package. The reaction from the floor, which is perpendicular to the floor as usual. Okay, and now we have to analyze the weight in these two axes, okay, that are perpendicular to each other. Okay, so if that angle is theta, then this angle is theta as well, and the reason is because this line is perpendicular to this line, and then this line is perpendicular to this line, which means that the inscribed angles are equal. Okay, let me remove those lines because it's confusing. Okay, so this component is going to be M1G cosine theta, and this component is going to be M1G sine of theta. Okay, too many things at once. I'm sorry, guys, but it's a complicated problem. Now, let's start answering. So, part A, okay. So T is M2 plus M3 times G, right? Where we are using these equations here for the buckets. Since they are in equilibrium, then T should be equal to 0.65 times 9.81 or 6.38 newtons. Okay. What else do we have going on? We have that the reaction force, this N, is equal to M1G cosine theta. This is because the package is not moving in this direction, right? So N is M1G times cosine theta. Let's actually find sine theta and cosine theta. So tangent of theta, which is what they give us, is sine of theta over cosine of theta. This is an overkill, but I just wanted to do it this way. So sine square theta is tangent square theta times cosine square theta. So sine square theta is 16 over 9 times cosine squared of theta, which you can write as 1. Actually, no. Let me be careful. So times cosine square theta, which means, let me think, we can write sine square theta as 1 minus cosine square theta is equal to 16 over 9 times cosine square theta. So 25 over 9 cosine square theta is 1. So 5 over 3 times cosine theta, excuse me, is 1. So cosine theta is 3 over 5, which means that sine of theta is 4 over 3 times 3 over 5, or 4 over 5. Okay, so now that we have cosine of theta and sine of theta, we can find n. So n is, so let's calculate it. So 3 over 5 times 1 times 9.81 or 5.89 newtons. Okay, let's turn the page. Okay, so far we used the equation from the bucket, the equation, the y component for the package. And now in the x direction, so the x direction is now, I mean, for the package, this is the x direction, this is the y direction, okay? You have those axes rotated a little bit, but the main point is that F plus the tension is equal to M1 times G times sine theta, because we also have equilibrium there. So T plus F is M1G sine theta. This allows us to calculate the friction. So the friction is M1G sine theta minus T, or 9.81 times 1 kilogram times 4/5 for sine theta minus 6.38, which we just calculated. So that's 1.47 newtons. But F is mu times n, right? So mu is, in other words, 1.47 over 5.89, which yields 0.25. It's exact, actually, which is crazy. So 1/4 is mu. Okay, after so many calculations, we arrived at the answer, but it was the correct answer. So let's move on to part B. Additional identical blocks of mass 0.2 kilograms are added one at a time into the bucket until P starts to move up the plane. Okay, at the instant when P starts to move up the plane, there are a total of n blocks in the bucket. Question B asks to find the value of n and the magnitude of the initial acceleration of P. Okay, so this is now a different situation. So let's turn the page and kind of start over. But so let's draw a new scheme now, though. Okay. So this is the pulley, this is the bucket, which I will represent with a box. Okay, and this is the string, and this is the package. Okay, so now in the new situation, we will have, here we will have 0.45 plus n times 0.2 g. That's the force that pulls down. And then we will have a t, okay, that pulls up like before. But it's going to be a new t, okay? It's not the same as before, because now we added more mass, okay? So I'm gonna call it t prime. And the same t prime obviously pulls the object up. And again, we have m1 times g. And then the friction, since it's moving up, the friction is now in the other direction. So that's F. Okay, so that's theta, that's m1 g cosine of theta. That's n prime is going to be different again. Okay, and then m1 g sine theta, that points down. Okay, so now we have two equations. So t prime is going to be equal to 0.45 plus n times 0.2 g at the moment just before it starts moving, okay? Because eventually we will need to calculate an acceleration. So let's assume that this is still in equilibrium, okay? So that's the first equation. And also t prime is also equal to f plus m1 g sine theta, okay? But this is equal to mu times n. Actually, n is the same as before. I don't know why I denoted it as n prime. It's the same as before, okay? Mu times n plus m1g sine theta is the new tension. So this is equal to 0.25 times 5.89 plus 9.81 times 1 times 4/5. So t prime is 9.32 newtons, which we can plug into here. So we get 0.45 times 9.81 plus n times 0.2 times 9.81 is equal to 9.32, which means that n times 1.96 is 4.91, which means that n is 2.5. So we need n equals to 3, since we need to have an integer amount of blocks, right? I mean, you cannot have 2.5. Okay, so we solved part 1 pretty much. And we are ready to solve part 2. Okay, and the part 2 asks, let me remind you. So in part 2, they ask us to find the magnitude of the initial acceleration of p. Okay, so since the body starts accelerating, we will use the same equations, but now we don't have equilibrium anymore. Okay. So assuming that the acceleration is down, right, and consequently up for the pi gauge, we have from M1, we get a new equation which tells us that T prime minus F minus M1G sine theta is M1 times A. And from M2, we get 0.45 plus the 3.02 times G minus T prime is equal to 1.05 A. Okay, so this is equation 1 and this is equation 2. So both of them are valid at the same time. So from 1, we get, actually this is T double prime now, okay? Because now things started moving, so it's not the same T as this T that we just calculated before, okay? It's different because now it starts moving, okay? So T double prime minus 9.32 is equal to A, okay? And 9.32 is mu times the vertical force, which is the same as before, minus m1g sine theta, okay? And from 2, we find that 10.3, by the way, what did I write there? Sorry. 3 times 0.2 kilograms, because we add 3 blocks, right? So 10.3 minus T double prime is equal to 1.05 A. We can add these two equations to get rid of T double prime, right? So we have 10.3 minus 9.32 is equal to 2.05 A, which yields A equal to 0.48 meters per second squared. Okay, so this was question 7. So I'd say 6 and 7 were a little bit hard because there were many things involved and many things changing, but I hope my explanations were clear. Let me know what you think about these videos in the comments. I'm getting close to monetization, but it's not there yet. I mean, you need to complete 4,000 watching hours. I mean, your audience has to complete that, not me. So hopefully at some point I will start making something out of this channel. So thank you for those of you who are following this channel and provide comments and suggestions and things. I'm gonna see you in the next video, guys. Bye.